Hello everyone. I have to say the USACO 2022 February contest is a great contest. The first two problems are just kind of easy, chill, but not too easy for silver. And this one, even though it's not easy, this is actually really hard, but it's actually good. It's a good problem, unlike 2023-2024 season or the season that we're in right now, the 2024-2025 season. The problems are hard, but they're not actually good. They're just kind of disgusting in terms of both the thinking and the coding. But anyways, back to the problem we're looking at today is the USACO 2022 February contest silver problem 2 of robot instructions. You can first look at the problem yourself. All right, the problem statement is short, which is part of why it's a good problem. That's just an important quality for all good problems, is that usually like 90% of the time a good problem has short problem statements. So basically, you have a robot and you're controlling it to start from 00 to xgyg. And now you have a set of instructions that you can choose to give this robot, and you're trying to determine the number of ways that you can select these instructions so that we reach xgyg. And there's at most 40 instructions. Just notice that range, which is really important for this problem. All right, you can once again pause the video and try this yourself. All right, I assume you thought about this. So first of all, the first thing that we notice is actually not the range, is that these instructions, these end instructions, do not actually affect each other, which means they do affect each other, but the order doesn't matter. That's the first notice. Is that we can implement these instructions in any orders we want. Knowing that, we can actually kind of go towards the state compression DP way, if you guys know what that is, in which we basically use a binary number to brute force which instructions we choose, because if the order doesn't matter, it's just 0 or 1, meaning we choose it or not. However, n equals 40 actually does not work, because we usually, for state compression DP and all those binary number enumerating problems, n is 20, and this number range is actually kind of strange in terms of if it's twice as big, which means like 80 or 100, the problem is probably looking for n into the fourth solution. Or if it's half the size, then the problem is probably looking for a 2 to the nth solution. But 40, well, this is actually the best part about this problem. I don't remember when's the last time that I actually saw a silver problem with a technique that I didn't know, and this was the first one. This problem, the technique is called meet in the middle. And it's actually quite smart because with n being 40, notice that we can just basically divide it in half and then do the state compression technique, do the 2 to the nth. It's basically 2 to the nth, but twice. But how do we do that? Well, meet in the middle is basically thinking, instead of, for half the instructions, for 20 out of the 40 instructions, instead of moving from 0, 0 towards the goal, we move the goal, but in the opposite direction. So if an instruction, we decided to get it into the second half, well then if it's, say, 1 and 1, meaning you move up 1 in x and move up in 1 in y, well, that turns into -1, -1, in which you move the goal x-axis down by 1 and the y-axis left by 1. So we basically have half the instructions moving moving the robot that Bessie has, and half the instructions moving the goal until we meet them in the middle. And then so basically we do 2 to the 20th for the first 20 and then 2 to the 20th for the second 20. We record the results of where the robot / goal is after choosing these sets of instructions, and then we check how many pairs work, and then we add up that for the answer. And the code is actually surprisingly short. Even though we had the DFS, but DFS is just template DFS, so there's not really much to it. And we have a find function, but all these are like reasonable. They're not like disgusting like the 2023 or 2024 season. So that's why I actually like this contest. So I have detailed process for my thinking / struggling during mock contest in the comments after the code. You don't have to look at that, but I strongly suggest looking at the code and the explanation before the code and in the code, because those actually explains what the code is about. And yeah, this is a good problem, and thank you so much for watching this video. I hope after this you know how to solve this really good problem of 2022 February contest silver problem 2 of robot instructions. Thank you. That was a good problem, but for the grind report today, I'm just gonna be honest. It's terrible. I'm falling off so much since, if you remember, December 24th. That day I grinded for 10.5 hours, and now it's just like 5 hours a day, which is not nearly enough. We have 21 days left until January 24th. And if I fail January, I don't think I have a chance in February or US Open, considering the difficulty that these two contests had at least the last few seasons. So I really need to start locking in. And today, basically, what I did is I mocked the 2024 December. If you can notice, this is actually the most recent contest from literally a few less than a month ago. But I did not mock the silver because I already took the silver and I failed it. But I took the gold actually, and I got cooked, completely cooked. All three of these problems, I only got half the credit for the first one. The second and third, I just kind of gave up. I probably could have gotten a little bit of points, but not that much. And it just got completely cooked. The first one, even after looking at the solution, is really, really difficult. It took me like, what, 3 hours for just this one problem. So that's actually what I did today. That's all I did. I mocked this contest. I gave up halfway, and then I solved this problem, and now it's already 10:30, and I don't have any time to do these two. I had to do them tomorrow. So yeah, I'm falling off in terms of both problem solving skills and studying time. So that's not good. Considering we have 21 days left, let's lock in. All right, thank you for watching.